Hello. In this lesson, we're actually going to get our last tool for solving quadratic equations. So far we have three, and here are three examples that use each of those tools once. And so I'd like you to try them. So probably on a scratch piece of paper or wherever you completed your last homework assignment, it'd be good to jot down these three so you have a specific example of using each of the tools we have so far to solve a quadratic equation. So I'm going to talk about each of them and why each tool would be appropriate for the one that you're going to try. So this first one is I'd encourage you to try to solve it by taking a square root. The reason why square root would be ideal is because there's no x term that would get stuck. You can easily get the squared item by itself and then use a square root. So you use square roots when there's no x term that would get stuck. So that's what I mean by x term, there's no x to the first powers. We only have x squareds and number terms. You use completing the square if there's an x term. And you have a statement like an x squared and an x are on the same side and it's equal to a number. In that case, you can manipulate the left-hand side of the equation using the steps we did in a prior lesson in order to get a perfect square and then take a square root. So you use completing the square when you have x squared and x on the same side and it equals a number, and you can make a perfect square on the left-hand side. The last one is actually the oldest one we did. We use this for multiple units. We solve by factoring. If you have your x squareds, x's and numbers all on the same side, it equals 0, and then you can easily factor it by finding two numbers that multiply to make the constant term. So multiply to make this term, and then add up to make the middle term, then you should try to solve that by factoring. So that's a brief rundown of when you use each one. I'd encourage you to pause the video now for a few minutes to try these and see how far you get before we go over them, so you have an example of each of the skills and before we get our very last one. So this is not in the note packet. This is just as an aside. So pause the video now, give each of these a try, unpause it after you've had a chance to try. I want to see each of them worked out. Okay, let's go over them. Let's zoom in just one at a time. Here's the first one. I said solve by taking a square root. You need to get the squared item by itself first, so you subtract 2 and then divide by 3. You get x squared equals 16, and then you can easily take the square root of 16. It's going to be plus or minus 4, so not too bad. The second one is by completing the square. This one you're going to have to use decimals for, so we have x squared. Here's my little box showing what I did. Instead of placing all 6 x's here, I did 3 and 3, and then I see I need to add 9 to each side. I add 9 to the left-hand side to make a perfect square. That's going to make x plus 3 squared. I also add 9 to the right-hand side to keep the equation balanced. Then I take the square root. The square root of 17 is not a perfect square, so I used a decimal approximation of 4.12, a little bigger than 4 because 17 is a little bigger than 16. That means that x plus 3 will either equal positive 4.12 or x plus 3 will equal negative 4.12, and then you subtract 3 and solve. So you can see that takes a little bit more time, but it will work. The last one is solve by factoring. What numbers multiply to make negative 4 and add up to be 3? It'd be positive 4 and minus 1. Those are your factors, and your two solutions then would be negative 4 and positive 1. And those are your three tools. You have square roots, completing the square, and factoring. And the order in which I would check them is as follows. I would look to see, can you take a square root? Because that's pretty quick. You take a square root if there's no x terms. If there is an x term, I would check, can you factor it? Because these two are very quick. If these two do not work, it means right now you'd have to do completing the square. But as we saw with the second example, completing the square takes some time. It's got some steps to it. And so there is one more tool that we can use. It's actually directly related to completing the square, and it's called the quadratic formula. And here's how it was derived. We're not going to derive it in this class, but I'm going to show you where it comes from so that you just understand and don't think it's just some math magic. The idea was this, and the quadratic formula is a very old formula. It's hundreds of years old, and the concept is actually almost 1,000 years old. So in order to solve by completing the square, here's a process done with numbers. And so what do? Well, they want to get x squared and x on the same side, so they add 7, then they divide by 3, so they have x squared, because you need a single x squared term, and you can see it leads to some fractions pretty quickly, but you can do it. You go through, you make a perfect square, you take a square root, and then you solve. So it can be done, but as you can see, it's a pretty labor-intensive task. So the concept was, let's do it with just variables, and if you do it with just variables, you'll get to a formula that works every time. So you can see, let's just follow the first few steps. Over here, they added 7, so what would I do? I would subtract c in the first step. Then they divided by the 3. In this case, that'd be an a, so they divided everything by a. So divide by a, divide by a. And so you can see they just use this example with numbers and mimic it with variables. I just want you to appreciate that's all this is. This is just repeating the same process on the left-hand side with just variables. When you do it, you get an end result that is a formula. This formula can be used to solve any quadratic equation. It can be used to solve even ones that you could do square roots on. I wouldn't do it if you can use square roots because square roots are much quicker than doing this formula, but this formula is like your tool that works every time. The downside is it has a lot of steps. So what we're going to do is we're just going to write down the formula and use it, but I want you just to understand and appreciate the formula came from completing the square with just variables. It didn't come from magic. It came from just meticulous mathematical logical steps. So the quadratic formula is what this is called. It is used when all other tools to solve quadratic equations will not work. It allows us to solve equations of the form ax squared plus bx plus c equals 0. Note it has to be equal to 0. And this is what the formula looks like. It says your x-intercepts, your solutions for your quadratic graph will be at negative b plus or minus the square root of b squared minus 4ac, and then all of that divided by 2 times a. A, b, and c are your numbers, your coefficients. A is your coefficient for x squared, b is your coefficient for x, and c is your constant term. Notice there's actually, look at this, there's that negative b over 2a that we saw before. That's your vertex's x-coordinate. The plus or minus tells you how far to the right and how far to the left you need to go to get your x-intercepts. So it's related to the negative b over 2a that we use for finding the vertex's x-coordinate. But this is the formula that we're going to use. Let's look at it in an example. So we're going to use the following equation as an example of applying the quadratic formula. Why would I use the quadratic formula on this one? Because it's got a 2 that will not divide out evenly with 4 and negative 3, so I can't simplify to maybe do factoring. It has an x term, so square roots won't work, and completing the square would be just as labor intensive. So this is a great example of using the quadratic formula because of all the other tools won't work well. And here we go. Let's first write down what a, b, and c, well, first need to check it equals 0. So, right, it has to equal 0. That's a check. Let's write down what a, b, and c are. A is equal to 2, b is equal to negative 4, and c is equal to negative 3. Then I'm going to write down what the quadratic formula is, and then I just plug in and simplify. The quadratic formula says my solutions, x, my x-intercepts will be at negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now I just drop in. Wherever I see an a, I put a 2. Wherever I see a b, I put a negative 4. Wherever I see a c, I put a negative 3. So this will be negative of a negative 4, so I'm going to put parentheses around that, plus and minus, plus minus because I need 2 solutions. It's a quadratic. b is negative 4, so I get negative 4 squared minus 4 times a is 2, c is negative 3, all divided by 2 times a is 2. So when I drop everything in, it looks like that. Now, do not try to go typing this whole statement in the calculator. Okay, it's like eating a pizza and trying to eat the whole pizza in one bite. Okay, very difficult. Do not try it. Do one bite at a time, one piece at a time. Use order of operations. Order of operations says do parentheses first, and the square root is an implied parentheses. So I would start simplifying in here first. Everything else will just kind of come along for the ride. You can simplify little parts, but don't try to do all of it at once. So x equals negative of a negative 4 we can do right now. That's going to be a positive 4. Plus or minus square root. Now let's do the inside of here. Negative 4 squared is negative 4 times negative 4. That's 16. Now, minus, this is 4 times 2 is 8, times negative 3 is negative 24. So this is minus a negative. I'm going to write that as a plus. You should notice, look, it's subtracting and a negative. Those two are going to end up making a positive. All divided by 2 times 2 is 4. Everyone okay with that? Okay. Now I can do this without having to rewrite everything. 16 plus 24, let's just do that right now. That's 40. If you wanted to rewrite it all as one step, go ahead and do so. But I'm going to just write it as that. So this just becomes the square root of 40. If you want to, write it down as a whole other step. Okay? Now I need the square root of 40. That is not a perfect square, so I'm going to have to use a decimal approximation. Square root 40, 6.32. So x equals 4 plus or minus 6.32 all divided by 4. Okay, now I need to split it into my two answers. X either equals 4 plus 6.32 all divided by 4, or x equals 4 minus 6.32 all divided by 4. I would simplify the whole top before dividing by 4. If I add 4 here, that's 10.32 divided by 4. Or if I subtract, so 4 minus 6.32 is negative 2.32, all divided by 4. Divide by 4 to get your final answer. 10.32 divide by 4, 2.58, or negative 2.32 divide by 4, negative 0.58. And there's your two solutions. You can see the quadratic formula takes some work. It's not difficult, it's more just organization. Let's use Desmos to check and make sure we found the correct x-intercepts, the correct solutions. You could also plug these back in for x in the equation, they should work out. If I use Desmos to check, if I type in the equation, 2x squared minus 4x minus 3, negative 0.58, positive 2.58. They're correct. So there you go. Benefit of quadratic formula is it would work. It works always. I mean, you could go back and let's look at one of the warm-up ones. You could do the quadratic formula on this one right here, solve by factoring. A would be 1, B would be 3, C would be negative 4. And you could do it. It would take quite a few steps. So you'd get the same answers that we got here. You get negative 4 and 1, but look, factoring is so much quicker. So factoring doesn't always work, but when it does, it's quick. Quadratic formula always works, but it's slower. Let's try one more, and then I'll have you try one, and that'll be it. What are the solutions to this one? Again, I'm going to use the quadratic formula because I have a 3 that won't divide everything out. So I'd give away that you're going to use the quadratic formulas when your quadratic equation won't simplify, and you have an x term, so you can't do square roots. Notice, though, you need to have the equation equal to 0 first, so I need to subtract the 8 over. And I'll have 3x squared plus 5x minus 8 equals 0. Now, I'm going to be very just meticulous, detail-oriented. A is 3, B is 5, C equals negative 8. Write down the quadratic formula. It's negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I would write that down at the top of the homework for today, just so you have it right at the top of the page you can reference. Here we go. Dropping in wherever I see an A, I put a 3. Wherever I see a B, I put a positive 5. Wherever I put a C, I put a negative 8. So this is negative of B is positive, so negative of a positive 5. That'll end up being a negative 5, but we'll do that here in a moment. Square root 5 squared minus 4 times A is 3 times C is negative 8, all divided by 2 times 3. So when I drop everything in, it looks like that. Again, I would focus on simplifying in here first. You can do this negative 5 and down below 2 times 3 to make 6, but don't try to do more than that outside of the square root at first. So this will be x equals negative 5 plus or minus square root. 5 squared is 25. Then this is 4 times 3 is 12. 12 times 8, negative 8 is negative 96. It's minus a negative, so this will be a plus a 96. Again, minus and then a negative is going to end up being plus, all divided by 6. 25 plus 96, that's going to be 121, so plus minus square root 121, all divided by 6. The square root of 121 is actually, 121 is a perfect square. So the square root will be an integer. It's actually 11. You can type it in your calculator. Square root 121 and C, it's 11. So I'm going to get x equals negative 5 plus or minus 11 over 6. Now I need to split it into my two answers. So two answers are as follows. X equals -5 plus 11 divided by 6. X equals -5 minus 11 divided by 6. -5 plus 11 is 6, and 6 divided by 6 is 1. So there's one of my answers. -5 minus 11 is -16, and -16 divided by 6, that one's not going to be an integer answer. You're going to might have to use a decimal approximation. It's going to be -2 2/3, so -2.67. And there's your two solutions. Let's use Desmos to check. It's right here. Take away the second one. Do x-intercepts, -2 2/3, and 1. There they are. So the quadratic formula is a foolproof way, because it always works, of giving you the x-intercepts without having to factor or use square roots. The downside is, as you can see, it takes some work. It always works, but it's the longest method, kind of the give and take of life. Okay? I am going to ask, let's go, actually I'll zoom in just real quick in case you missed any steps. Just go through it real quickly in case you want to pause anything. Each step shown right there. Okay, I'm going to ask you to try one now. So it's your chance to try the following. Be aware, first thing you need to do is get the equation equal to 0 first. So you need to subtract the x over, and you need to write it from highest power to lowest power. Mistake I see people make is they'll do 2x squared minus 7 minus 1x, and then they'll say, oh, a is 2, b is -7, and c is -1. No, you need to rewrite it highest power to lowest power. 2x squared minus 1x minus 7 equals 0. And then a is 2, b is -1, c is -7. b is always the coefficient associated with the x to the first power. So there's your first step guide. Now use the quadratic formula to solve. Pause the video now to give maybe 2 minutes for you to try or more. Once you've gotten as far as you can, unpause it to see it worked out. So pause the video now, please. Okay, here's all the steps. As the first thing I said, right? A, B, and C, identify them. Then drop them into the quadratic formula. So there's the quadratic formula. Should be x equals. I don't know if that just got erased or if I just don't want to write it. Dropping everything in. Negative. Why did this become a positive one? Because negative of a -1 made it be a positive. Everything else looks like that. And then you just go simplifying. Inside the parentheses first, you get 1 plus 56. That's 57. The square root of 57 is going to have to be a decimal. You split in your two answers, and there's your two answers, 2.14 and -1.64. That's it. Thank you very much, and have a good one.